Hi everyone, this is a quick homework help video for question 11. This is grade 11 maths methods and it is exercise 7.04. So we're presented with a diagram of a box, and they say that the box is made of a piece of square card which is 12 centimetres on the side. So let's just start adding a few dimensions. That means from there to there was 12 centimetres, and likewise across the other edge there was 12. They go on to say that they cut equal squares which are x by x from the corners. We don't know the size of x, and then they fold these edges up to make a box. So if I try to draw this thing in a sort of a 3D perspective view, it'd be somewhat like this. It's like a shoebox without a lid. Now, what would the dimensions of my box look like? Well, the little edges here, x, they would represent the height of this box, as these rectangles would fold upwards to be the edges, and this square in the middle would be the base. It might be easier to work here. How long is that distance which represents the base of the box? Well, it's all 12, and I've got to subtract x from both sides. So it's 12 take 2x. Now, because it's symmetrical, it's square, the base is a square. So what's the volume of my box? Well, it's the length of the base by the width of the base by the height of the box. And we just worked out that the base was 12 take 2x, and the width was 12 take 2x, and the height was x. Now I can see that 12 and 2 have a common factor of 2, so that's probably best if I put 2 outside 6 take x, and then I'll do it again for this one, and I still have x there. Now 2 by 2 is 4 by x, would be 4x all collected, and 6 take x squared. That's my formula for the volume of the box. What a lovely formula. Now, I think I would like to get my graphing calculator going and see if I can draw this graph and get an idea of what that looks like. Just find where I keep my calculator app. Here it comes. So that's going to cover up half my beautiful picture, isn't it? There we go. I'll just move to the side. So I'll go onto the graphing app, and I don't want that. I want the formula 4x 6 take x squared. Let's draw this. Oh, that's a bit of a weird picture. Let's go to the initialize the window view. Still a bit weird. Right, so let's looks like this is going off the top of the page here, and there's something happening there. I might move to the right a few steps. Now I need to go up to a greater value on the y scale. So let's leave the x ones alone. Maximum y value, let's push that up to 50. We might jump up in steps of 10 to make it not so bad, and let's see how that looks. Oh, we're still off the top there, so we might go and push that y value up to 150. Let's see how that looks this time. That's better. So there is a very lovely looking cubic equation. It would be cubic because by the time we square this term, it's quadratic, and then multiply by that x, it's cubic. Cubics can have up to 2 turning points. That's good. And the question then went on to say, draw the graph. Yes, done that. Oh, I should have watched. It said from 0 to 6. Well, that's okay. That's 0, 1, 2, 3, 4, 5. So that point there looks like 6. Good. So that's the part where we're interested in. Don't really mind about that bit over there. It says, at what value of x does the box appear to have maximum volume? Well, somewhere about here, somewhere in this region. Now I can press the G-solve key and ask the calculator to identify the maximum. And as long as it's within the view window, it does so. There it is, x equals 2. y equals, that's a bit hard to read, 128 I think. And interestingly, the derivative equals 0. Yes, a tangent line at that point would be horizontal now, wouldn't it? I can probably do a sketch of a tangent line. Now, if I just move that point of interest, let's hope it goes on to the spot we're interested in. Perfect. So the tangent line at that point is horizontal. That's why it says dy dx equals 0. That's where x equals 2. And that must be the highest point, because as you start to go down the other side of the hill, the tangent pokes up the other way. As you hit the maximum, the tangent flattens off, and as you go past the top, then the tangent starts pointing down again. So I think we have pretty happily determined that the maximum value of the box is if x equals 2. I think that's a lovely question. Thank you for asking, thanks for watching, and I'll see you next time.